Imagine standing before a mirror that doesn't reflect your face, but instead reveals the memory of existence itself. A mirror that doesn't show the present, it captures light that has been traveling across an expanding universe for billions of years. What appears before you is not who you are today, but a glimpse of what once existed. Every photon carries a message from an ancient cosmos, preserving moments that unfolded long before Earth, the Sun, or even our galaxy took shape. That is the extraordinary purpose of the James Webb Space Telescope. It wasn't built simply to see farther into space. It was designed to look backward through time, allowing humanity to witness the earliest chapters of cosmic history, the birth of the first stars, the formation of the earliest galaxies, and the dawn of structure in an otherwise dark universe. For decades, astronomers believed they had a reliable picture of how everything began. According to the standard cosmological model, the universe emerged approximately 13.8 billion years ago in the event we call the Big Bang. In the first moments, space expanded rapidly, temperatures fell, and pure energy transformed into the fundamental particles that would later form matter. As the universe continued to cool, hydrogen and helium became the first atoms, filling space with immense clouds of gas. Yet despite the presence of matter, the cosmos remained dark. There were no stars, no galaxies, and no visible sources of light, only a silent universe waiting for gravity to begin its work. Over millions of years, tiny fluctuations in the distribution of matter slowly grew stronger. Gravity gathered gas into increasingly dense regions until the first stars finally ignited. These pioneers illuminated the darkness and eventually assembled into the first galaxies. According to long-standing theories, this transformation should have been gradual. The earliest galaxies were expected to be small, chaotic, and irregular. Complex structures such as organized disks, spiral arms, and stable galactic systems were thought to require billions of years to develop. Looking farther into space, and therefore farther back in time, should have revealed an increasingly primitive universe. But the James Webb Space Telescope told a different story. When Webb focused on regions that earlier observatories saw only as faint smudges, it uncovered remarkable detail hidden within ancient light. Instead of finding only immature collections of stars, it revealed galaxies that appeared unexpectedly mature. Some displayed clear rotating disks. Others possessed bright central cores surrounded by well-organized stellar populations. A few even hinted at spiral structures, features that conventional models suggested shouldn't have existed so soon after the Big Bang. At first, researchers questioned whether the distances had been measured correctly. Astronomers estimate cosmic distances using redshift, the stretching of light caused by the expansion of the universe. If those measurements were inaccurate, these galaxies might simply be closer, and therefore younger, than they appeared. Yet repeated observations continued to confirm the same conclusion. These galaxies truly existed only a few 100 million years after the Big Bang. In cosmic history, that is astonishingly early. It's comparable to discovering a fully developed city in a place where only the first foundations should have been laid. The surprises didn't end with their appearance. By studying the light emitted by these distant galaxies, astronomers can determine which chemical elements they contain. The results revealed another unexpected mystery. Many of these ancient galaxies already possessed significant amounts of carbon, oxygen, nitrogen, and even iron. These heavier elements weren't created during the Big Bang itself. They are forged inside stars through nuclear fusion and scattered across space when massive stars explode as supernovae. This entire cycle, stellar birth, evolution, and explosive death, requires time. Yet somehow, these elements were already abundant in galaxies that existed astonishingly early in cosmic history. This suggests that the young universe may have been far more active than scientists once imagined. Perhaps stars formed at extraordinary rates, burned through their fuel rapidly, and ended their lives in violent explosions that enriched space much sooner than expected. Rather than evolving slowly, the early universe may have experienced an era of breathtaking acceleration. Even more puzzling is the discovery of enormous black holes in this ancient epoch. Supermassive black holes, containing millions or even billions of times the mass of our Sun, were expected to require immense stretches of time to grow through mergers and continuous feeding. Yet Webb has uncovered evidence that some of these giants already existed when the universe was still remarkably young. Their rapid appearance challenges current theories. To explain these observations, scientists are exploring several possibilities. One idea suggests that certain black holes may have formed directly from massive clouds of collapsing gas, bypassing the slower growth process. Another proposes that interactions involving dark matter may have accelerated their formation in ways we do not yet understand. At present, none of these explanations has been confirmed. And that uncertainty is precisely what makes these discoveries so exciting. The shapes of these early galaxies raise even deeper questions. Instead of appearing distorted and chaotic, many exhibit remarkable symmetry and organization. Rotating disks, balanced structures, and coherent forms emerge at a time when the universe should have been too turbulent for such order to exist naturally. It's almost as though an unseen framework guided their evolution. One possible explanation involves dark matter, the invisible substance believed to make up most of the universe's mass. Rather than serving only as a gravitational scaffold, dark matter may have played a far greater role in shaping the architecture of galaxies from the very beginning. Perhaps the most profound discoveries, however, are found not in galaxies or black holes, but in chemistry. Webb has detected complex carbon-based molecules drifting through distant clouds of interstellar space. These molecules are considered important ingredients for the chemistry that eventually gives rise to life. The astonishing part is their age. The light carrying these chemical signatures has traveled for billions of years, meaning these compounds existed long before our solar system formed. The building blocks of life may have been widespread across the universe from its earliest eras. If that is true, then the chemistry needed for life may not be a rare exception. Instead, it could be woven into the very fabric of the cosmos. The implications are profound. The deeper Webb explores, the more the universe challenges our expectations. Rather than revealing a simple progression from chaos to order, it presents a cosmos where galaxies formed faster, structures emerged earlier, and complexity appeared far sooner than existing models predicted. Every new observation answers one question while creating several more. Each discovery reminds us that our understanding of the universe remains incomplete. The James Webb Space Telescope has done far more than extend humanity's vision. It has transformed our picture of the early universe, revealing a cosmos that was dynamic, energetic, and astonishingly complex almost from the very beginning. Perhaps the most humbling realization is this: every photon captured by Webb began its journey billions of years ago, long before Earth existed, before life emerged, before any conscious being could wonder where it all came from. After crossing unimaginable distances, those ancient messengers finally reached our telescope, carrying fragments of a story that is still being written. We built a machine to see farther than ever before. Instead, it revealed how much remains unknown. The deeper we look into the universe, the more mystery we uncover. And somewhere within that ancient light, the true history of the cosmos is still waiting to be discovered.